Hello everyone, welcome to SM Tech World. Today we are going to solve the LeetCode problem number 116. Problem name is populating next right pointers in each node. So basically we already solved the problem using the BFS. So in that example we were using some extra spaces. But today for this example we are going to see how we can solve the same without using any extra spaces. Okay. So let's quickly check the problem description, then we will directly jump into the solution. Okay. So here you can see that this is the given example, right? We will be given one perfect binary tree. That means all leaves are on the same level, and since it's a binary tree, it can have only two children, left children and right children, and this will be the structure of the binary tree, right? So it will contain one value, it will contain left child, right child, and they introduce the new attribute that is next. That next attribute we need to calculate. So let's try to see the logic to calculate the next. Okay, so if you check this example, right here, this is our binary tree, and so what we will do, so suppose we need to calculate next for each and every node, right? So we will initially start from 1, and for 1 I will check is there any node right side to 1. If yes, then my next will point to that node, else it will point to null. Okay, so we can see for the first level there is no right side node, right? So obviously it will point to null. Similarly for the second one, I can see, okay, 3 is in my right side, right? So you can consider this is the first level, this is second level, this is third level, right? So in this case 2 will point to 3, and similarly for 3 there is no node right side of 3, right? So in this case it will again point to null. So you can continue in the same logic, like 4 will point to 5, 5 will point to 6, 6 will point to 7, and then again 7 will point to null because there is no node after 7 or right side of 7. Okay, so this is the example. So in the last video we already saw that, right, how we can use BFS and extra queue. Then we can traverse each and every level at once, then we can easily calculate the same. But for this example we will see how we can do the same without using extra spaces. So what we will do, we will take only one variable. So probably let's consider the level. So since we are using BFS and queue, right? So queue was the extra space, right? So for what we will do here, we will take only one variable level. So then I will traverse to the left. Okay. So I will take another variable, probably head. That will be a temporary variable. Then what I will do, I will set the next pointer for the left side first. Okay. So I know that it's pretty easy, right? So suppose this is your root or head. So next of this will be, so head dot left dot next will be obviously the right side one, right? So using this way we can directly point the left to right. Okay, so that this is done. Now we need to point this section only, right? This section also, right? So we will traverse level wise, so that we are using this level variable. So at first I will start from here, then I will set the pointer of 2 to 3 and 3 to null because we don't have anything in the right side. After that again we will come here. Okay, after coming to here I will again set the left, I will go to the left side. Okay, so I will go to the 4, and then again I will set it to the right one. Okay, now how we can set for the right side? So this is our main logic, right? In that case I will check what I will do. So ideally 5 should point to 6, right? So now I know that next of 2 is 3. So to set the right next, what we will do, I will go back to my root and I will take the next. So in this case 3, then I will point it to the left. Okay. So using this approach we can easily solve it without using extra variable. So let's quickly see the code that will surely give you much better understanding. Okay. For this example we are going to use JavaScript to write the code, or you can use any other language. The logic will remain same. Okay. So what I will do here, I will at first check that my root is equals to null. So since it's JavaScript, you can write like this, and if I see, okay, if it is null, then we can directly return root from there only. Okay, what else? Now we will take one more extra variable. So let us take one variable, let us name it as level only, and inside that I will store the root initially. Okay, so now I will run while loop. So I will keep traversing to the left side only, right? So I will come here, then again. So that means whenever I will change my while loop pointer, that means I am done with one level. Okay, so for each and every level we are going to run while loop, right? So it will look like this. So while level dot left is not equals to null. So if it is not equals to null, then I will take another pointer, let us name it as head only, and initially it will point to level. Okay, so at first we will start from the 1 or root, right? So again I will take while, and now I am in the first level or 0 level, right? So I will keep checking all the nodes for that particular level 0. Okay, so in this case we have only one. Now let's quickly write the logic for the same. So what I will check here, I will check that my head should be not equals to null. Once I know that my head is null, that means I am done with one level. Okay, then I will move forward to the next level. So okay, so in this case I can see, okay, this is my node 1, and in this case it's not equals to null, right? So now I will traverse this level. Okay, so what I will do now, I will set head dot left dot next. So that means we are setting this pointer, right, to 3. We are making this connection. So it should be obviously head dot right. So this is easy, right? So we are done with the left child. So suppose this is my root, I will set the next of left next to the right one. This is straightforward, right? Now I will check that if my head dot next is exist, means it is not equals to null, then we can set the right one also, right? So for right one, formula will be head dot right dot next, and it should be head dot next dot left. Okay, so let's quickly see what we are doing here. So you can see, right? So suppose I am here in this case, right? I will set 4 to 5 using the first formula, right? Using this formula only, right? Now I will set the next of 5. So to set the next of 5, this is my head. Currently my head is pointing to 2. What I will do, I will go back to the next. So next of 2 is 3. So my pointer will come here. Then next of left, so that is 6. So using, now we can connect 5 to 6. So we are writing that only, right? Head dot right dot next equal to head dot next. So I will go, my counter will move from 2 to 3. Then I am taking the left. Okay, so left of 3 is 6. So this is how we are making the connection between right to left. Okay, and once we are done for that particular level, we are going to change the head pointer, right? So it should be head dot next. Okay, so using this line number 31, basically we are checking for each and every. So suppose I am here, so I will check 3, and again whenever my pointer will come to 3, I know, okay, my next is null, then I am done with that level, right? So we are maintaining that thing using the line number 31, and once we are done, now I will move forward to next level. So it's easy, right? So it should be level equal to level dot left, and once we are done, we can return the root. Okay, so I think that's pretty much. Let's quickly run the code and check the fast test case is passing or not. Okay, I think it's passing and it's giving us the expected answer. So let's quickly submit the same. Okay, you can see our submission is successful. Okay, and we are not using any extra spaces. So let's quickly go through the code once again, what we are doing here. So we are taking two while loop, and we are taking only extra variable, and then that this is not dependent on my input size or input tree height. Okay, so one while loop for each and every to keep tracking the total number of level. So what that means, so suppose I am here, so I will start here initially, and I need to iterate through the all 3 level, right? So first while loop is for that only. So initially I will start from here. Now I am taking the second while loop, right? Second while loop is basically for each and every level we may have multiple nodes, right? For the first level I have only one node, but for the second we have 2 nodes, right? For the third we have 4 nodes. So we need to keep checking all the nodes, right? So suppose I have 4 nodes, so I need to keep traversing through all the 4 nodes, right? So that we took this second while loop. Now what we will do here, what we are doing here, so now once we are here in the root, I am setting the left side. So for setting the left side, it's pretty easy, right? It should be left dot next should be head dot right. So easily, right? And for the right side, suppose for this example, right, what we will do, so I know that my 2 is next is 3, I will come to the next and I am going to left. And now using this logic, we are just identifying the connection for the right side. Okay, so this line number 29, and once we are done, I will move to my next node for that particular level. Okay, so I think this is pretty much for this video. If you like this video, please subscribe to our channel, and thanks for watching. Bye bye.